So this is right triangle trigonometry, which is the beginning of chapter 4. The first thing is values of trig ratios. So that's where we're starting with. We have values of trig ratios. So first we're going to look at the trig functions. And to do that, typically we use SOHCAHTOA. I've always seen it written horizontally, and I don't really know why people do that. I think it makes a lot more sense if you write it vertically, because then SOHCAHTOA. And you can just write it down the margin of your paper, and then it's just there so you can see it. But if you do it this way, then you have sine is opposite over hypotenuse, and the O is over the H. And so it makes sense with what you're saying if you do it this way, as if to write it horizontal. You can write it however you want, use it however you like. This is the way I do it, just like over on the side of my paper, I write it out. So we're going to use SOHCAHTOA to find the trig functions. And when we do that, we are looking at a triangle, a right triangle. Alright, so there's the 90-degree angle, and I'm going to put angle theta over here, right there. So you have to define where angle theta is. And then across from the 90 degrees is going to be the hypotenuse. And across from angle theta is the opposite side. And then the leg of the triangle that's touching angle theta is the adjacent side. I'm also going to label this as angle A, angle B, angle C. Angles get capital letters for notation, and typically the side across from them get a lowercase letter of the same letter. So across from angle C would be a lowercase c, across from angle A is a lowercase a, and across from angle B is a lowercase b for the sides. Okay, so now we have our triangle labeled. If we wanted sine of theta, well, from SOHCAHTOA, sine equals opposite over hypotenuse. So opposite over hypotenuse. And we would know from this triangle diagram, it would just be whatever value of B is over the value of C. So we could write it as B over C, if those are lengths. And then cosine of theta. The ratio of cosine theta, we go from theta, well, cosine, C-A-H, A is on top of H, so that's what our ratio will look like, A over H, adjacent over hypotenuse. So ADJ over HYP. And that ratio is the value of A over the value of C. And then we have tangent theta. Tangent is the ratio that does not involve the hypotenuse. It's only looking at the legs, opposite over adjacent. Opposite over adjacent. So here it is B over A. Alright, so these are the trig functions, and there's their ratio value. I do have 3 more, but they're the reciprocal functions. So next is reciprocal. The reciprocal functions, just like anything else, if it's 1 over. So we have 3 of these. Because if we had sine of theta, what if we had 1 over the sine of theta? that would be cosecant theta. So this is CSC theta, and that stands for cosecant. So this cosecant, is it A-N-T or E-N-T? A-N-T, all right. And then we could do the same thing with cosine. If we had cosine and we had 1 over cosine theta, that would be secant theta. So secant theta equals 1 over cosine theta. And then if we wanted the reciprocal of tangent theta, that would be 1 over tangent theta. It would be cotangent theta. And vice versa. So we could also say that we could do it that way, or we could say that sine theta equals 1 over cosecant theta. So, I mean, they just go back and forth. It just depends on what you have and how you want to write it. So I'm going to just bring it up here and write the reciprocals over here so it's all together in one spot. So we have sine theta equals opposite over hypotenuse, which is b over c, but it's also equal to 1 over cosecant theta. So sine theta is equal to 1 over cosecant theta. And cosine theta is equal to 1 over secant theta. 1 over secant theta. And this is also 1 over cotangent theta. And the reason I brought it back up here to the top and put it with this list so you can see it all together is, if you notice, sine starts with an S, but its reciprocal function starts with a C. Cosine starts with a C, but its reciprocal starts with an S. So it's the opposite letters whenever you do the reciprocals. Cotangent and tangent, I mean, I feel like that's pretty, you're not going to mess that one up. But sine, its reciprocal is the one that starts with C. Cosine's reciprocal is the one that starts with S. All right, so then the next part is an example. So we're going to use cosine of theta equals 2/5 to find all other trig values. Example. All right, so we have that cosine theta equals 2/5, and we know that cosine is adjacent over hypotenuse. All right, so since we have that information, we can sketch our right triangle, and once we fill in all the pieces of the right triangle, we could write any of the trig ratios that we want to. So that's going to be the plan. There's 90 degrees. Across from 90 is, well, I don't really need the hypotenuse, and the hypotenuse I know is 5 because it was given to me right here. Oh, I'm going to mark theta down here in the bottom. You can put it wherever you want as long as you're consistent. I'm going to mark it in the bottom right because I just like to put it there. Adjacent is 2. Adjacent is adjacent to the angle I'm talking about, so it's on the bottom. That's my 2. So the one I don't know is over here, this other leg, the opposite leg. So I can use Pythagorean theorem to solve for that. So I could do a squared plus 2 squared equals 5 squared. So a squared equals 25 minus 4. So a equals the square root of 21. And that's the other piece of my triangle, square root 21. Now that I have all three lengths for all three legs of the triangle, I can just write the 6 trig functions. So I have sine of theta, sine is going to give me opposite over hypotenuse, so square root 21 over 5. I already have cosine, but I'm just going to go ahead and write it anyway. Cosine theta is 2/5. And tangent theta is opposite over adjacent, so square root 21 over 2. It's the numerators of sine and cosine. Alright, so now that I have the 3 original trig functions, I'm going to write their reciprocals. So cosecant theta, CSC, that's going to be 5 over the square root of 21. And then secant theta is 5 over 2. And cotangent theta is 2 over the square root of 21.
So you just flip them?
Yes, it's just the reciprocal. And we're not going to worry about rationalizing the denominator for right now. You're not supposed to have a radical in the denominator, but that's really not the focus of this lesson. We're just going to flip it for right now. And that's it. That's the answer for this problem because it said find all of the values. All right, so then the last part for today, yes?
Like I know you did Pythagorean theorem because you like you're labeling like the angles, right? Because does it matter which things to label? Does that make sense?
Like this angle?
No, like the ABC. Like does it matter where that goes?
Not really. It just depends on the problem. I just to name it, I named the angle, and typically the notation is just the side length is across from that one. So it's not always those. It's just that those letter A, B, and C letters are to match the picture I drew.
Okay.
Like really you would mainly want links for at least for 2 of those, right? Or at least 1. All right, so then special right triangles. That's the next part. And it's just the 2 that you have already worked with before. The first one is the 45, 45, 90 triangle. So in the triangle method, because I know that there are some teachers teach it one way and some teachers teach it another, so I'm just going to put it both ways. With the triangle, if this was my 90, that means I have a 45 and a 45. So 2 angles are 45 degrees each. 1 angle is 90 degrees. So if this side is x, or if it has a side length of 1, the other leg is the same length. And the hypotenuse is that length times the square root of 2. So it'll be 1 times square root 2, which is square root 2. Or I know some other teachers use the tic-tac-toe method. So you just set up your tic-tac-toe grid. The first column is your angles, 45, 45, 90. The second column is their values, or the formula you're going to use, x square root 2. And then you have to be given a side length to go any further. So if this side length is 1, then and across from 45 is 1, So if the angle is 45, the side across from that angle, if it has a side length of 1, then that tells you that x equals 1. If x equals 1, then x equals 1. And x square root 2 equals 1 square root 2, which is square root 2. So you could use the tic-tac-toe method, which is really the same thing as the triangle. It just depends on which way you'd rather do that. And it's their relationship to each other. And the other one is the 30, 60, 90. 30, 60, 90 triangle. So the tall one has, the skinny angle has to be the 30, the fatter angle is the 60, and there's a 90. So if the side length across from 30 degrees is 1, then the side length across from the 60, the other leg of the triangle, is 1 times square root 3, so square root 3. And across from 90...
Sorry to interrupt you. Can I borrow a marker real quick?
Yeah, sure.
Shouldn't take too long. Marco?
And across from 90 is going to be 2 times the length of that leg. If the length was 1, 2 times 1 is 2. All right, that is just with the triangle method. I'm pretty sure Coach Bala teaches it that way. I've always taught it with the tic-tac-toe. 30, 60, 90. Again, it's your angle measures. And then in the middle is where you put the formula. So 30 gets an x. Then you have x square root 3, and then 2x. So if you're given that the length of the leg across from 30 is 1, now you know what x is, and you can plug it into the other two formula bars or formula sections to get the value of those side lengths. So if x was 1, then it's 1 square root 3, so it's square root 3. If x is 1, it's 2 times 1, so it's 2. Your assignment today is page 227, because we skipped chapter 4. And it's numbers 1 through 8. And number 9 through 17, odds only. So 1 through 8, all of them. I'll do it this way. And 9 through 17, odd.